Hey guys, this is Mainak. Today I'll be designing a building in STAAD and RCDC. This is the building, and before designing any building, we need to know the prerequisites of the building design process. So here the plinth height is 600, foundation depth is 2 meter, and according to the soil test code SBC at 2 meter is 220 kilonewton per meter square. Floor to floor height is 4.5 meter, and the building will be designed for G plus 1, that is 4.5 meter into 2. Let's start. So as you know, the first step for the design process is the marking of the columns. So this is the plan we have received from the architect, and he has already marked the columns here. Initially, as a structural engineer, you should check whether these columns are sufficient or not. And if these are sufficient, then it's okay. If not, then you can suggest additional columns. So I'm going to make a building the building design according to this placed columns, and let's find out whether this is okay. So the first step is I need to make the uh, center line for these columns and import the data in STAAD Pro, or I can mark the coordinates and then enter the data in STAAD Pro. So let's go ahead. So as you can see, I have numbered and placed all the columns, and I have made some minor adjustment according to the alignment. So sometimes while placing the columns in the architectural plan, the alignment is ignored. So to make sure that the ones which are bottom aligned are bottom aligned, so that minor adjustments I have made. And it's okay if you want to just place the beams, because when you place the beams, then you get a true idea of what should be the column positions, what should be the corrections in the column alignment once you place the beams. And so the sizes of the beams I had taken according to previous experience, or you can use the span formula to assume the size of the plinth beam or the roof beam. So I've taken 300 into 450 based on the previous calculations. But if you don't have any experience, you can start from any size and you can just design. Okay, so I'll take these initial sizes for columns and beams for the designing. Now, once my beams are placed and the column positions are checked, the next thing which I want to do is I want to make the center line. So we need to make the center line so that we can do the next steps, and then we'll proceed further. So as you can see, the center line of this plan has been made. But if you want to import in STAAD Pro, you can see this is in mm. So we have to convert this into in meter. So let's convert this into meter first, and then we'll see. So I'll just copy this file here, and this one we will use a scale. Let's see, enter. So using this scale, we can convert this. So if we just give a scale of 0.001, then it will be converted into mm. So this is the file which you can convert into mm. So just select this, and if you just select this and just click on DXF out OUT, and this will be saved. So just to save it in a particular location, or you can open a new file and then you can copy this file from the and set the units to meter, and then copy the file to here like I've done. And then after that you can delete this file which is in mm. Okay, so this is the file in meter, and you can see the units here. This is in meter. Now this can be imported in STAAD. So just save the file and center line for STAAD, right? STAAD, save this, and then again DXF out and center line, same change, just right here, center line for STAAD. Save the file here. The file has been saved. Now we can open the file in STAAD Pro, and first of all paste the columns and then do the remaining steps there. So once you have the DXF file ready, open STAAD and simply go to file, and then we go to import and then DXF, and then select the file which you want, and then Y up, and then click on OK. Set the units to meter, because the file is in meter, and kilonewton, and then click on OK, and then the file will be imported. Take some time as project. So once the file is imported, just click on Ctrl plus A. So if there see there is an extra thing there, just delete this for now. Yes. So press Ctrl A once again and then go to Beam Tools. In the Beam Tools, this is the Connect edition. Okay. So we have to in the other edition also the option is the same, but we have to intersect the beams. Okay. So we have to do that. So simply just select Ctrl plus A and then go to beam tools and then intersect beams and then click on OK. So you can see beams are created. Now the normal steps will be there. First of all, we will select all the nodes which has the columns. So we'll go to view and we'll go to the top view here. And from the top view, we'll select all the nodes which has the columns using the node cursor. So we'll go and we'll use selection, select node cursor, and then using control, we'll select all the points which has a which has a column. Okay, so I'll do that, and then we'll continue. So once you've selected all this, so simply go to geometry and go to the option of translation repeat. So this is the icon for the translation repeat. Click on it, Y direction, and my plinth height is 0.6 and foundation depth is 2, so it will be 2.6. Since it is downward direction, it is minus 2.6. Click here once and then just click on OK. So then you'll see in 3D view, go to 3D view. You can see this. So nodes, so if you just select, go to select node cursor, the nodes are there but it is not visible. So to make it visible, press shift plus N, you get the node, and shift plus K you get the node, and shift plus N you will get the node now. So I could have used link step here, but you can also join it now. So using add B, I join it one by one like this. Okay, so I'll fast forward. So now I have completed this, so just click on escape to just escape from this, and now we can just copy this to the next one. Since this is an industrial building, so we'll be applying slabs in this floor as well. In normal buildings, you can apply not apply slabs on the plane level, since all the pressure is taken by the compacted soil and the PCC or the plane cement concrete, but we'll apply slabs in this case. And in the upper story, there will not be slabs in the portion where you have the staircase, but here in all the blocks will have the staircase, sorry, the slabs. So to add the slabs, you can just go to add plate and then click the 4 corners. But now here, if you just do it from the top view, then it might select the lower part. So for that, we have to go to view and we have to go to front view and just escape twice and select only this portion, right click and click on new view. Just click on OK, and then you can do everything from the top view, right? So the top view, now we can go to geometry, add plate, and we can add plate like once, but it's preferred that the way in which the construction will be done or the design will be done, we will add plate like this. So one by one, we'll add plate in all the location. So I'll fast forward this. So I've completed this. Just to see the effect, go to view and go to 3D rendering to check whether in all the areas we applied the slab or not. Okay. So once this is done, so this portion is done. Now next we can do the next floor, which will be the translation repeat option. Okay. So we will go to view. Or simply you can just select the column nodes and then we can do link steps and then translation repeat, but actually we need to copy the entire flow because we need to copy the intersections as well. So we'll go to view and we'll go to front view, and we cannot use link steps because there are other intersections as well, and we'll use the option of geometry. We'll go to translation repeat, Y direction, and the root to floor height is 4.5 meter. And we'll do single step because in the next step we will copy along with the columns. Okay, so just click on OK, and then we'll go to the 3D view. Sorry, we'll go to view and we'll go to 3D view, and here now we'll join the columns here. We'll go to geometry, we'll go to beams, and we'll join all the points which has the columns. Okay, So you get by this point you couldn't do link step because there are intersections which don't have columns. Okay, so I'll join all the columns one by one. It's important that you go to view and you go just display whole structure just to check whether the points which you're selecting are okay or not. Otherwise you'll not know which points have intersection and which don't. Another important way, just to make it more easier, you can just select this and then you can go to the isometric view just to check whether all the points which are selected have the extensions or not. Then you can continue with joining the columns. So once you do all the columns, go to select and go to parallel to here, beams parallel to Y. So you can check here if there is any column which you have not joined or any column you have wrongly joined, like this, for example, this point doesn't have column. So you can check like this whether you have joined any wrong points. So once this is done, then our job is comparatively easier. So what we can do, we can go to the front view and we can simply use this, and then along with this columns we can select this carefully like this, done, and then we can go to geometry, translation, repeat, Y direction, and our step is 4.5 meter, and we don't have any step about this, only the headroom portion we might have to do, right? So this portion is done, and now we get to select the supports. So go to support and create a support here and select the supports. So this is the connection between the column and the footing. Supports have been created. Now for the slabs here, what you can do, you can go to select and go to node cursor and then select all the points here. Not node cursor, just select the plate cursor. Select all the plates. Now just look into the architecture. So from the architectural plan, we find that there is only one staircase here, and the remaining portion there is no staircase or there is no lift also, because this is basically a single story, so there is no staircase or lift. So only in this portion we will not have any slab in the first floor. Okay, in the remaining portion we can have. So minimize it and click on the STAAD, right? And now we can simply what is the should be the best way, and simply right click and click on new view, click on OK, and let's view it from the top. So only when you select this with the help of your node cursor or plate cursor, select everything, that is all the plates except this plate. So this is selected. Now we can go to, let's go to view, this view, and display whole structure, and this is selected. Now we'll copy this to the next two floors. So for that, go to geometry, use translation, repeat, Y direction, and it is 4.5 meters, and the steps are, number of steps are 2, and then click on OK. So now we can see the effect. You can go to view, you can go to 3D rendering, and you can see the effect here, right? So like this you can see the effect. So the plates have been assigned. Now let's come for the column placing. So initial column and beam we have already chosen what should be the sizes. So let's do that. So first of all we'll go to properties, and first of all we'll define the slab. So slab thickness here, let's go here to our portion of thickness. So go to thickness, and here slab thickness of 150 will define. Let's see. Okay, we'll add and we'll close. So we'll just assign to view, assign, and yes, slab properties have been defined, and then we'll define the columns. So we have two columns which are rectangular in sizing here. This plan you can see there are two columns particularly. So this column size is 230 into 450 here, and this column size is also 230 into 450, but the orientation is different, right? So let's see, let's apply. So ZD, so first of all let's apply that one, that is we'll apply first of all ZD is 230, and YD is 450. Click on add, and another one we'll just reverse the case here. So it will be 0.230, it will be 0.450. Right. So we'll just apply these two columns in particular. So you can apply it from the 3D view as well, just to see the CAD file and apply it. So the first one will be this one. Okay, select this, all these three, and click on assign to selected beams and assign. And the second one will be this one. Just like this. Okay, should have selected it from the top view, but it's okay. Assign to selected beams. So this is actually this column, right? The selected beams. Okay, this has been selected, and I have to do one control, select this, assign, and yes. Okay, two columns have been assigned. Remaining columns are of the same property. Okay, initially define and rectangle, and this will be 0.5 into 0.5. This is the column size which will be given, and let's assign this first. Okay, so to assign it, the best way, we can go to the view and we can go to the top view, and here we can assign it. Just select this, and we can, so once we select here like this, suppose for example like this, we are selecting like this, let's see, or else there is another way. Just go to view display whole structure, select parallel to Y, and then we'll deselect the two beams which you have already assigned, right? R2 and R3. So select, control click, control click, control click, control click, 1, 2 and 3. So these two are deselected, remaining will assign to selected beams, assign, and yes. So the column properties have been assigned. Now for the plane beam, so we'll define the plane beam rectangle, and it will be 0.3 into 0.45. This is the initial plane beam size which I'm doing. Click on add, click on close, and just go to view, go to front view, and then select this, and then just assign to select beams, assigned, and yes. And this is the case here. And then for the roof beams, we can assign the same size initially, later we'll change, but I'll define using a separate command so that I can change it later, right? 0.3 into 0.45 it will be. Okay, let's do 0.5 initially, 0.5, and not change, it will be new. Define rectangle 0.3 into 0.45, and let's check this one also. That added the 0.3 and it will be 0.45. Change. So it's the same. So now we'll go to view, front view, and select this and select this. So, and as I select it, assigned, and yes. So like this, you just see, go to view, go to 3D rendering, and you can see it here. Just maximize it, and our structure is complete. Your modeling part is complete. We have assigned the loads and all. Okay. So our location is the Sihor district of Madhya Pradesh. So in the India map, you can see that this is the Sihor, and in the IS code, you can see this is the zone 2 and this is the zone 3. So MP is surrounded by zone 2 and zone 3. And if you look carefully and if you just properly superimpose, you can find that the Sihor district is in zone 3. So it roughly just escaped this, and it is actually in zone 3 of the seismic zone. So we are going to just write here, so this is the seismic zone 3, and and the other things are for the external wall, the load for the 230 wall, that is the 18.4 kN per meter square will be calculated, and for the internal wall, wherever the walls are there, there will be 9.2 kN per meter square. And if you want to calculate for the parapet wall as well, so because we want to do that also, so let's calculate for the parapet wall load, and parapet wall, if we just take this as 1 meter, so it will be let's take 10-inch wall, okay, and let's take this entire thing calculation, and 10-inch parapet wall will take, and only the difference will be in this height. So this height will be 1 meter, so 0.23 into 20 unit weight into 1 is 4.6. So 4.6 will be the parapet wall. So I am taking red brick into consideration. If you take fly ash brick or if you take double AC block, the design will be better. So we know all this. Now we'll apply this live load factory for medium weight equipments. It is 5 kN per meter square, which will apply seismic zone 3. So the design will be a little bit on the higher side as compared to the other previous things for zone 2. So this is it. These are the things. Let's apply the loads. So we'll apply the loads one by one. Let's go and select this particular floor, right click and click on new view, and then we'll just click on OK, and then in the top view we'll go and we'll just select the portions where we have this load. So we'll go to, first of all we'll go to loading and go and define the seismic definitions first. Okay, so just click on the seismic definitions, click add on the seismic definitions from here. So seismic parameters, you can just select the IS code and then click on generate. So it will be zone 3, and then it will be RC. So now we will decide whether to go with OMRF or SMRF. Okay, so we'll go with OMRF for this one as well. I'm not considering ductile detailing, so just to go with medium soil for now. Damping ratio 5%, foundation depth will keep as 2 meters, and time period in X and Y direction we have to calculate. So for the calculation I've taken the highest length in X and Y direction is the highest length in X direction, highest length in Y direction, and as per this clause of the code for RCC buildings, so we have in X direction it is 0.14 and for Z direction it is 0.11. so we insert it right here. X direction 0.14 and Z direction it is 0.11. okay, so this is the case, and we are not considering ductile detailing, so that's why it is OMRF. So if it is seismic zone 4 and 5, you definitely need to give special consider ductile detailing, and you need to consider special moment resisting freight. But in some cases in zone 3 also we consider, but here we are not considering. If you consider ductile detailing, this structure will be little bit much more this heavy, and the reinforcement and the section size will be more. So in this case is not considering, but you have to check whether ductile detailing is applicable or not. If it is zone 3 and zone 4, sorry, zone 4 or zone 5, it is definitely applicable. Click on generate and click on add. So we'll close this, and all these things we'll do with the STAAD editor since it's easier. So we'll add the first load, and which is the seismic load in X direction, and click on add. So we can add the seismic load in both the direction, plus X and minus X, plus X minus Y, but seismic load in minus X direction as well we can add. But actually when we consider the load combination, the plus and minus, negative or positive, both the directions it is already taking, so it is not compulsory to consider plus X and minus X. So just consider in Z direction, because in load combination it will take the loads anyway in both the direction. Okay, seismic load in Z direction, and then we have the dead load, then we have the live load. And then if you want to check, you can add the model analysis as well. Okay, and you simply check whether the structure is stable or not. We cannot design by model analysis for now, so we can just check whether the structure is stable or not using the model analysis as well. Okay, so just add seismic and go to seismic loads in X direction and add it, close it. Seismic load in Z direction, and seismic load here we have the seismic load in Z direction, and click on add and close, and we have the dead load. So for the dead load here, we have the self weight first, -1 direction, that is the gravity direction. Close it, and simply go to view first and just display whole structure first. Okay, and simply let's add the load first, and then we'll just see self weight. You can simply assign to view here. Okay, no problem in that. And the dead load, first dead load which we'll be adding is 18.4, right? So add dead load here, member load, okay, minus the gravity direction 18.4, it's the external wall. Then we have 9.2 minus 9.2, and then we have minus 4.6, okay, click on add. Then we have floor finish, and floor finish will be minus 0.5 for the tiles and marble, whatever you just put, you just go to the floor finish, click on add. Okay, here I have added this, sorry. So this floor finish load, minimum range and maximum range you have to provide. So minimum range will be 0 for this one, because in this ground floor we are considering the slab here. So minimum will be 0 and maximum will be 4.5 into 2. So 4.5 into 2 is 9. So this maximum range will be 9. 9.1 you can do. Okay, change this. So like this you have considered. And then the remaining things will assign here. Live load also, let's take add here live load in the, let's take the area load, flow load is better, -5 we are taking the live load, and the minimum range is 0 for this one, and maximum is 9.1, and click on add and close. So dead load, live load, these things are added. Now we'll one by one add this flow loads, sorry, load of the valves. So to add this, we need to add, we go step by step here. So since the loads on the first floor and this will be taken as the same, so we can do it at once, or else we can just simply do it one by one. Okay, so what we'll do, we'll go to view and we'll go to front view, and we'll select this one, and we'll press Ctrl and select this one, since both the loads are the same. So, and then right click and click on new view. Okay, and when you go in the top view, if you select, suppose let's say we select this, and then in the isometric view both the things will be selected. So like this we can do it. So let's select the external, select first of all, we'll click on 18. Now we'll select all the external walls, simply like this, we'll select all the external walls. So and then we'll assign it. Okay, let's select this. So the 10-inch walls have been selected. This is assigned to selected views, assign, and yes. Similarly we have to do for this as well. Okay, so this is selected. Now let's select all the beams. So the internal walls have been selected, and then click on assign to selected views, assign, and yes. So once this has been assigned, now we can move on to the parapet wall. For that we'll go to the front view. Okay, the front view, and display whole structure, and then we go to the front view, and then we will select this, and then right click, and then new view, and select the top view from here, and then we apply the places where we have left the parapet wall. Okay, just select this, and then we select using control like this. So once this has been selected, just select this, and then okay, we have to select this again. So now just select to assign to selected beams, assign, and yes, parapet wall load has been assigned. Okay, so just go to display whole structure, and then you can see the loads which has been applied, live load which is automatically applied. Okay, so then seismic load in X direction and Y direction, this is also applied. Now simply we'll go to save the model first. So after saving the model, and we'll go to utilities and go to command file. So just open the command file here. Next, just zoom in a little bit. We'll go down, and here what we'll do, here we have the member load. The dead load will just copy completely. and in the seismic definitions where we define this, we just enter and paste it. So some modifications we need to make. So we will wait EIGHT wait this negative direction. Here also, here also. This will be weight. Negative. Okay. 0.5, and this is the seismic mass source. So just copy this and paste it here. So live load is 5. So the live load is 5, we'll take 0.5% of 5, which is 2.5 in the seismic mass source time. So it's 2.5 for the seismic mass source, which will give. And then I will just press Ctrl plus S. This portion has been modified. Then we suppose this. So if there is an error, it will show up in the model. Otherwise, it's okay. Okay, just taken this simply analyzing the field and analysis commands. You can just statistics, watching more shapes called. You can just add all now and click on add and then close, and then simply you will run the analysis. Okay, run analysis and check whether there is any error in the model or not. So there is no error in the model, so it's okay. So you can do model analysis for this as well. So before the design, you can do model analysis. So you can go to miscellaneous commands and you can see cut off mode shape here, and 6 is okay because 3 in each, we consider 3 in each floor, and 6 is okay. And yeah, then go to loading, and in the loading part we'll add the model load. So just click on add none, and this will be the model load. Caps lock was on. So it will be a none category, and then click on add. And here simply we can just add the loads, add self weight in extraction, and self weight in extraction will add 1 minus 1. Really it doesn't matter here because this will be added. So you can just simply add this self weight load in one direction, and self weight in y direction, not prepared, z direction, and close. So for the self weight, let's analyze this. Okay, you can add other loads as well, but for the self weight, let's just do and assign to view, assign and yes, select this, assign to view, assign and yes. So this has been assigned. Now model load, just click on add here, and frequency, use model calculation. Okay. And missing mark mode, if you want to consider the below the plinth, then just consider this, otherwise just click on add and close. So simply now we can go to analysis and design, run analysis, and we'll see the results here. Okay. Now just simply we will go to the utilities and analysis output, and we'll see here. Let's see mass participation factors. Double click on this, so we'll see whether it is 65% or not. So this, according to IS code, these three, summation of these three should be more than 65. 44 plus 22, so it's okay. So it's more than 65%, so it's okay, right? So just close this. So this thing is okay. And if you want to see the effect here, I can just go to let's say post processing mode. Okay, post processing, and you can just select the model load for now, because you just see this model load line. Okay, and we go to dynamics, and simply you can just check the mode different. For the different mode, you can see this, you can see the animation as well, just 115, and mode, apply and OK. See this animation, note, and 250. See, apply and OK. See for the mode 1. So the mode 1, mode 2. So like this, you can see this various thing for various modes. So our structure is stable as per the mass participation factor by factor is considered. So we can just proceed for the design. Okay, so we'll just simply go to analytical modeling, like analytical modeling, and we'll go to design, right? So we'll go to design and then design the structure, or else what you can do, you can just design the structure directly in RCDC as well. So we'll do that, we'll design the structure directly in RCDC. So just simply advanced concrete design, which is the RCDC, will open. Simply this is accept and then. So I've selected this, and first of all we go for the column, and let's go for the column first, and we'll just we change the file location. Okay, STAAD profile is this one, and just create new project. So the file, if you just open directly RCDC from STAAD Pro, it will be created in the location where you have the STAAD, in the folder which you have the STAAD file. So firstly, in the input data, we can change the the sizes of the columns also you can change. So let's see what are the data we have. We have this sizes of the data, level data we go, and here we'll just change this. The three types of columns will change this FE550, M25 grade of concrete. Cover will do 40 mm, 40, and here also 40. So this is the file, and 40 mm this grid size is selected in here, and then we go to this settings and basic load cases. Just define this load cases for now. This is big load in X direction, this is big load in Z direction, this is the dead load, and this is the light load here. I will not take this model load, this was only for checking and analysis, not for designing. So this is okay, and then we just click on OK, and this is for irregular structure. This is a regular structure. Okay. So then click on OK, and then just simply go to settings and just check the reinforcement and design settings here. So reinforcement design settings are okay, by default it's okay. Just click on this. So it will take some time. So this is the last file. So you can see some columns have passed, some columns have failed. Okay, so and that is the reinforcement here. It's okay. So check the columns which have failed, and we will just try to fix it. So the columns which have failed, for example, in this column which has failed, just right click and redesign column, and then we have here 550. This is given here, and just copy and paste this, and then redesign and accept. So 12, 20 and 425, I think you can accept that, no problem in that. Okay. And for this one also, I think this one also we can do 550. Done. I'm just checking the reinforcement. If there is any unrealistic reinforcement, then we have to change this one. Let's write down this one as well. There is any problem. 50. Okay, so checking for any 32 mm bar. So if it is in 32, then probably it is a little bit unrealistic here. So here again, design column. That's right. accept. This one also. So all the columns are passed, so these are the results, so there is no problem in that. Just press Ctrl plus S. Now we want to save the files so that we can make the drawings in AutoCAD. So right now only 2 files are needed. So first of all I have to save this file which I have already done, and go to report, and we have the text schedule, and since we've done non-backlight design here, so the non-backlight schedule will be this one, and save this file. Just save this file, and I'll just do this as RCDC results. RCDC results, and then we'll just post this, and this will be our column schedule, and the column layout is going to need. This one is our column layout with numbering here. So column layout, right. So this is done, and then we can do the footing as well. File, create, save the file first. File, create footing design. Some columns are very close, so there will be some combined footings also. So input data has opened here. You can go to settings, you can go to general settings. Here let me change the grade here, okay, and use net SBC of 220, and then soil density, water table, this is okay. Foundation depth is 2 meter. Click on OK, and then we have this. All the load combinations are taken, and for the sizing we'll add on just the load combinations. So designing the footings here, and let's see the results. So yeah, this looks pretty much good, and let's see the sizes here. These are the sizes which I'm having here, so it's okay, the sizes for these footings. So first of all, save this file. This is our footing layout. And then we need the footing schedule. Of course, schedule vertical, it doesn't matter actually. So we have the footing schedule, so we'll save the file. Not save the project. Ctrl plus S, the project will be saved. RCDC results. So STAAD file, I think the structural program, it is footing. Right. Now we'll save the file. RCDC results. Footing schedule. Just type footing here. Then we save the file. This is done, and then save the file once again, and then we close it. So now it's time for the beam design, right? So let's go for the beam, and first of all we'll go for the plane beam. So I set 0 and create new project. Set the file. So go to this settings, then enforcement settings, and then we'll just change the grade here by 50. Click on OK, and then we'll just change the load combination here. We have to define it again. See the design. So this beam design groups failed. We'll similarly just do this. So let's see. Okay, this is okay. This is okay. And 300 into 450, actually 332. So this is okay. 332 comes in 2 layers and it's not okay. So you have to change this all this beam layers. So the designs which are not acceptable, actually we have to change that. And suppose for changing this, because this layer, I think this has 232 and 332 and 323 and 325. So how to change that? Just click on design. Here you have to change the size and change the depth here, and then we have to design. So suppose 300 into 500, so it will be more. 500, 500, 500. And redesign. Still it's 332 in the, actually in the next 2 sections it is more. These 2 sections are okay, V4 and V5 it is okay. In these 2 sections it is more. So I will not accept this. Suppose I unlock this. We keep this 300 to 400. Sorry, 450 was right. 450. 450. And this one, make this as 300 into 600. Let's see if it designs or something error. Yeah, this is more acceptable. 300 into 600, this it doesn't matter, it becomes 332 here. So I'll unload this and make this all 600 and then accept this. Also 325, 325, 325, 325. Now it's better. It's 225. So we'll accept this. So like this, I have to change all the design, as similarly we'll do for the root beam as well. So these are the design steps which you can do, and then after the design is complete, then I will just go for and put the text schedule and then the layout, and then I will make the drawings. So I have to complete this project. And after I complete, then I will show you another file of the detailed drawings, or the detailed drawings which are construction ready and which you can, or the proper execution in the field, and make another video. So keep learning. Thanks for watching. Bye bye.